All right, so find the elasticity. This is much different from what we're doing. If you go back, this is the same section we're in. I just copied it on the bottom of this. So we're going back to this function here, or this theorem, that elasticity is equal to negative x times d prime of x over d of x, where d of x is a demand function. So to find the elasticity, which is what they're asking us to do right here, which is in part A, E of x is equal to negative x d prime of x over d of x. So they've already given us d of x, which is here. And x is just, so what we need to do is find the derivative. And this is probably the most difficult part of this problem, because d of x is equal to 5x plus 500 over 30x plus 9. So we have to find the derivative of that. So which rule are we going to use? The quotient rule, very good. So we're going to use a quotient rule, and this is why it kind of becomes a little cumbersome because of all this division. So if you remember the quotient rule says if we have f over g, the derivative of that d by dx of a function is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Right, that's their quotient rule. That's like chapter 1 kind of recall. So our d prime of x, and we're just going to call the top here f and the bottom g, so we can work on it, is equal to g, which is 30x plus 9. You know what? Let's put it under here. 30, we need that room, plus 9 times f prime, and f is the numerator. So the derivative of that is just 5 minus f, which is 5x plus 500, times the derivative of the denominator, which would just be 30, all over the denominator squared. So that's 30x plus 9 squared. Michael, you okay with that? No, we could simplify this. All right, let's just simplify it a bit because it might make it easier. So we can distribute this 5 over this. That's okay, Jahan. We're doing one of the questions from 3.7. That's number 6. That's the last question on the homework. So that's 150x plus 45. And that would be minus 150x minus 1,500, 15,000. And you guys can check that arithmetic on some of that. Over 30x plus 9 squared. So here this will cancel out. So we're left with what's negative 15,000 minus 45? $14,955, I think, over 30x plus 9 all squared. All right, so I'm doing all of this arithmetic in my head, so if I make an error, please forgive me. So this is what d prime of x is equal to. So let's go back to the elasticity. Elasticity is equal to negative x times d prime of x over d of x. So we just found this d of x, right? This is what we just found. So now we can plug that back into the formula because we already add the x and we already add the dx. So our E of x, or elasticity, is going to be equal to negative x times d prime of x, which is negative 14,955 over 30x plus 9 all squared. And that's all over d of x, which was 5x plus 500 over 30x plus 9. All right, so theoretically, this is correct. The bad news is my MATLAB really won't accept that, right? So you probably have to do some simplification of this. So this is negative x times negative 14,955 over 30x plus 9. And this is all squared on the bottom, times 30x plus 9 over 5x plus 500. All right, so I'm not sure if you're following what I just did. Here, we're divided by a fraction. So when we divide by a fraction, we convert it to a multiplication. So all we did was we flip it and we convert it to a times. So it becomes a multiplication here. Now, we have 30x plus 9 on the top, which will cancel with 1 up to 30x plus 9 on the bottom. And this should give us a positive 14955 x on the top because of the two double negatives. We're multiplying the top. And on the bottom, we have 30x plus 9 over 5x plus 500. So this would be our elasticity function, assuming we made no little errors along the way. Let me see if they give me an answer. Plus 100. Their answer actually looks different from my answer, which means there's some arithmetic error in there. Michael, are you there? All right, so there's an error in here somewhere. It's arithmetic. The process is, I just want to make sure you understand the process that went down. Are you okay with that? All right, so it's just finding d of x like you did in the first 5 problems, right? And substituting that into the elasticity formula. So there's a lot of place for error in this problem, and obviously I made one somewhere. Now, how would we do part B? So that was the difficult part, like I said, and it's based on the derivative. To find the elasticity, all you'd have to do at that stage is plug in 3. For part B, we're going to find E of 3. So that'll be 14955 times 3 over 30 times 3 plus 9 times 5 times 3 plus 500. Now for part C, depends on the answer for part B. So it says at $3 per plant, which is what we just did, will a small increase in price cause the total revenue to increase or decrease? Well, it kind of goes back to what we're going to say earlier on up here. If elasticity is less than 1, it's inelastic. And a small increase will not change the revenue. If it's greater than 1, excuse me, it's elastic and a small increase will affect the revenue. It will reduce the revenue. And that's how you'd answer part C. It's basically a yes or no question. Let's see how they answered it. Their answer was it's increase or decrease. That's all they're looking for. And here their answer was actually decrease. So E of 3 was greater than 1, whatever that number was. And you guys could probably calculate it. So if it's greater than 1, it's elastic. And if it's elastic, change in price will affect change in revenue. That's basically it. Are we good on that, Michael?